Hello, calculus students. These are the same notes that we did on Thursday in class, but I know many of you were absent, so we're just going to start here again. I'm going to do some examples of integration problems, and then you'll have a chance to practice them and see the answers by the end of this video. Please follow along in the packet that you received on Thursday. If you did not receive a packet on Thursday, there's one posted on the portal in the online learning topic for you to print, or you can just write these on paper, whatever you prefer. Please note that your quiz over this section will be on Math Excel. When you do a quiz on Math Excel, there's a feature that locks your browser and everyone has different questions. So make sure you're truly trying to learn this information, both for the quiz and just because it's important to know for calculus. Don't forget, I have office hours every day from 10 a.m. to 11 a.m. and 1 p.m. to 2 p.m. if you have any questions over what we're learning. All of your assignments are going to be Math Excel assignments, but you'll be given 2 days to complete it because I know different schedules will keep you from doing it within an allotted amount of time. So for example, you have a 13.1a homework today on Math Excel. However, it's not due until tomorrow at 11:59 p.m. Please email me if you have any questions. So let's begin with 13.1, the indefinite integral. We talked about how it gives you the area under a curve, and it's the opposite of a derivative. Well, you don't always want to have to calculate the area under a curve every time you do an integral, so we have some integral rules so you can quickly calculate some integrals. The first one is the most common one that you're going to use, the power rule for integration. And so if you're taking the integral of something to a power, then that's going to be you add 1 to the exponent, and then you divide by that new exponent. The integral of e to the x is e to the x. Now all of these, since they're indefinite integrals, you need to put plus c. And the y for that is, if I have 3x squared plus 5, and I take the derivative of that, I get 6x. If I take the derivative of 3x squared minus 10, I also get 6x. So you have to account for that constant that could be added, but we don't know if it actually is. Number 3. The integral of 1 over x is natural log absolute value of x plus c. I use the absolute value because you can't take the integral, or you can't take the natural log of a negative number, so we have to use absolute value bars. Those are the 3 integration rules that you're going to use for this section. The next 3 rules are just some properties of integrals that will help you take integrals when they get a little more complicated. So rule number 4, if there's a constant out front, you can take it out of the integral before you apply one of the rules from steps 1 through 3. That'll make your life a little bit easier. Also, if you're adding 2 different functions together, you can break it apart so that you're taking the integral of f of x first, and then you take the integral of g of x second. And the third one is the integral of a constant is always going to be kx and then plus c. Note that variable could be something other than x, like t or m or z, whatever. The reason for that, I'll explain the y for that one too. That's not how you spell y. Think of k as being kx to the 0 power. Well, then if we apply the power rule, like rule number 1, you can take out the constant, and then you have x to the 0 dx, and then the integral of x to some power is you add 1 to the exponent and then divide by the new exponent. So that just becomes kx and then plus c. So that's why the integral of a constant is just kx and then plus c. It's easier if you just remember that instead of having to do all of these steps every single time. So those are all the rules for integration. If you need to pause or rewind at any time, don't hesitate to do that so that you can get all the notes down. Let's look at these examples here. The first one the integral of 5. So that's just a constant. So that's going to be 5x plus c. The next one has a constant out front. So I'm going to take the 9 out. And then the integral of e to the x is e to the x. So the 9 is still there. And then I take the integral, so the integrand symbol goes away, plus c. Number 3, I'm going to take the constant out, 5 integral x to the 7th dx. And then I'm going to apply my integral rules. The 5 is still there. I'm going to add 1 to the exponent and divide by my new exponent, and then plus c. Let's go to the next page and do a couple more examples. Now we get to apply some of the properties. This is 3 different pieces, the 4x cubed, the 2x, and the minus 1. So I'm going to break it up into different integrals. So I'll have the integral of 4x cubed dx plus the integral of 2x dx minus the integral of 1 dx. So in the first one, I can take out the 4 and then take the integral of x cubed. That's the power rule, where I add 1 to the exponent and then divide by my new exponent. The next integral, I can take out the 2, and that is x to the 1 power. That's the power rule. So I'm going to add 1 to the exponent and divide by my new exponent. And the last one is the constant rule, where that just ends up being 1x. Now I can simplify any fractions. In the first one, the 4's cancel, so I'm left with x to the 4th. In the second one, the 2's cancel, so I'm left with x squared. And in the last one, I can just write that as x instead of 1x. The last thing we need is plus c. And that's the integral. Notice how the integral symbol goes away once I apply the power rule. Number 5 is similar. We've got 2 different pieces, 2e to the x and 3 over x. So I'm going to take the integral of 2e to the x dx separately from the integral of 3 over x dx. So the first one, I can take out the constant, 2 integral e to the x dx. And then the integral of e to the x is just e to the x. The next one, I'm going to take out a 3. So then I have 1 over x dx. And then the integral of 1 over x is natural log of x. And the last thing I need is plus c. So what I want you guys to do right now is pause this video and try the practice problems down below. Then you can hit play to see the answers. This is beneficial so that you don't think you know what you're doing, because you can follow my video, and then when you try to do the Math Excel, you're totally lost. This will also give you an idea if you need to show up to my office hours and ask me how to do these. So pause your video right now and do these problems. Alright, I hope you found that these were pretty easy. These are the basic rules. So close your eyes one time, and when you open them, you'll see the answers. Hopefully you got all of these right, and you will be successful completing Math Excel homework 13.1a. That's due Wednesday at 11:59 p.m. Have a great day, guys.